Hi, I'm Greg Epple, Senior Solution Architect that works on the Microsoft platform at AWS, and today I'm going to talk to you about ensuring your Windows Server workloads are well-architected. So what is the well-architected framework? It's essentially provides you with prescriptive guidance on how to build and operate cloud-native architectures. It also contains a set of questions that you can use to measure your architecture against established best practices. And so the well-architected framework essentially provides a set of questions and design principles across 5 different pillars. And those 5 pillars are, these pillars cover fundamental areas that are often overlooked, such as operational excellence, security, reliability, performance efficiency, and cost optimization. And if you think about technology solutions, it's a lot like constructing a physical building. If you don't have a solid foundation, it can cause a lot of structural problems that undermine the integrity and the function of that building. So we believe that if you neglect these 5 pillars of security, reliability, performance efficiency, cost optimization, and operational excellence, when you're architecting technology solutions, it can become a challenge to build a system that really delivers functional requirements and meets your expectations. So, what I want you guys to take away from this this tech talk is how can you apply the well-architected principles, those pillars, against your Microsoft workloads? So when you can incorporate these into your workload, it will help you produce stable and efficient systems and really allow you to focus on those functional requirements and not keeping a solution up and running. So the focus of this talk is going to cover 5 areas within the lens of the well-architected framework. We're going to talk about architecture, about SQL Server, about identity and access management, the developer platform and tools, and the administration of Windows instances. So let's talk about our first topic. So applications on Microsoft Windows. You can run a variety of applications on Windows on AWS. It's not just Microsoft applications such as Dynamics and Exchange, but you can also run custom applications built in .NET, Java, Python, ERP solutions such as SAP, or BI solutions such as Tableau. We also have AWS Quick Starts, a variety of them, including several for Windows workloads. And these Quick Starts are built by AWS solution architects and partners. And they help you deploy popular solutions on AWS. These Quick Starts are based on AWS best practices for security, high availability, and reliability, and are meant as reference deployments that implement key technologies such as SharePoint Server, SQL Server, Active Directory, and Remote Desktop Gateway, to name a few. Now, before we go on any further, it's really important as we talk about these well-architected pillars that we discuss our global infrastructure. Our global infrastructure is comprised of 18 regions across 55 availability zones with 100 plus edge locations. Each region in our global infrastructure is comprised of 2 or more availability zones. Now, within each of those availability zones, we have at least 1 or more data centers. And each availability zone within a region is fully isolated from one another. So that means it has separate power powering the data center. It's placed on a separate floodplain. And so if you build your application across multiple availability zones, which you'll see in a lot of these reference architectures that I'll go over, you can withstand an availability zone failing. So you can build a highly available architecture of your application by leveraging our global infrastructure and how we construct our regions. Now here's an example of that, which is this is an Active Directory Quick Start. And you can see immediately that we have the AWS box, and within that we have a VPC, and within that we have 2 availability zones. So you can see everything that's in one availability zone, we have a counterpart in the second availability zone. And so this gives us a highly available architecture. You can see that there's 2 domain controllers, 2 NAT gateways, and 2 remote desktop gateways. Other things to call out on this, well-architected principles are around cost optimization. We have NAT gateway and auto-scaling groups. And NAT gateways are managed services that will scale up and down depending on the amount of traffic that needs to go through your NAT gateway. And before that service, you would have to run your own NAT gateway, and you may have to over-provision it to handle those spikes in traffic. With auto-scaling groups, again, it's It's a service that allows you to cost optimize your architecture so you can scale up and down the instances as needed. And so in this case, we're leveraging that for the remote desktop. I had already talked about multiple AZ architectures, and that's what gives you the reliability. As well as the security pillar and well-architected. You can see that here through how the remote desktop is used as an entry point into your VPC, as well as using a multiple subnet architecture. So you can segment your data by subnet, as well as performance efficiency, which is the last pillar. Again, NAT gateway and auto-scaling groups not only give you the ability to optimize your cost, but also make sure you have an efficient performance for your architecture as well. So it can scale up and down based off of need. Now here's a similar architecture diagram. This time this is that Microsoft Active Directory Quick Start that I just showed you, but this one is slightly different in that it has a hybrid component to it. So you can actually take that architecture that I just showed you and then connect it over direct connector or VPN gateway. In this case, we're showing a VPN connection to your on-premise network. And so you can use that connection to the on-premise network to replicate your Active Directory to the cloud. We also have another version of that first Quick Start I showed you, and this one, again, is available on the Quick Start site, is the ability to stand up in what's called the Microsoft ADFS architecture. So Microsoft ADFS stands for Microsoft Active Directory Federation Services, and it's Microsoft's SAML IDP. So this is what would allow you to be able to federate with AWS, to federate with other solutions that accept SAML 2.0. Here's one more quick start. This one is SharePoint. And SharePoint can be a very complicated installation. It has many components, and you can see here that everything is split up. Again, using that best practice of building across multiple availability zones. We have our web tier, our application tier, our database tier, and our Active Directory tier spread across 2 AZs. And we're leveraging NAT gateway and the remote desktop gateway as well. Now onto our second topic, identity and access management. And just going back to the well-architected pillars, obviously security is one of those 5 pillars, and it's a very important pillar. And so AWS Identity and Access Management enables you to manage access to your AWS services and resources securely. Using IAM, you can create and manage AWS users and groups, but you can also create roles, and you can use those roles and integrate them into your corporate directory. So Active Directory in the case of Windows. And you can leverage Microsoft ADFS, which we just talked about, as a way to extend your Active Directory into AWS. So it allows you to take your Windows AD users and assign them roles for access. Other functionality that IAM provides is multi-factor authentication, either through a virtual or a hardware token. And IAM also it's a key service. It's a fundamental building block of AWS, and it integrates with all AWS services. As we talk about security, a very common way to secure Windows workloads is to use a remote desktop gateway, which you may have seen in the previous architecture diagrams, but some people will call this a jump box or a bastion host. But the idea is that you set up a remote desktop gateway on the perimeter of your VPC, and then you allow access from your corporate data center into that machine, and then that will proxy additional RDP or PowerShell connections to your backend instances. So this is a very common architecture that we see our Microsoft customers use on AWS. As we talk about security in AWS, we have to talk about Microsoft Active Directory, and I've shown some previous quick start diagrams where you can spin up an Active Directory instance or architecture on AWS. But it's very common that you would want to actually somehow connect this to your Active Directory you already have on-prem, and there's a few ways that we see our customers do this. One of the more common ways is to have a single domain that goes across multiple sites. And so you do this by establishing a VPN or direct connect, and then you would have that exact same domain, that single domain, so in this case company.local, and you would have that in AWS, and you'd have it on-prem, and you would replicate over that VPN or direct connect connection. And basically how you would make this work is in Active Directory, you would use the site and services functionality to create another site within your Active Directory topology and add AWS to that site and services. So this is very common when you want to extend your data center to AWS. Another topology that we see people use with AWS in their on-premise data centers is a separate domain per site. And so in this case, the previous example is a subdomain. This is a completely separate domain. So you have, in this example, company.local on-premise. We still use that VPN and that direct connect to establish that connection with AWS, but we have a completely separate domain called company.cloud. And what we do here is we actually set up a trust relationship between those two different domains. So as opposed to using a subdomain, this is a completely separate domain from what's on-premise versus what's in AWS. And when you go with this route, what you can actually leverage one of our managed services called directory services. So you no longer have to run Active Directory on the EC2 instance. You can actually just use AWS Directory Service, managed Active Directory, and that allows you to spin up an Active Directory instance in the cloud that is highly available, that spans those availability zones, and will take care of managing the underlying resources. And another really common thing that we see people do with their Active Directory is doing federation, and they do this with Active Directory Federation services. There's other partner solutions like Okta and Ping Federate, but really any SAML 2.0 IDP solution can federate with AWS. And so in this case, you have your AD users on-premise in the box on top, so on-premise, authenticate against Active Directory, and then you use something like ADFS, Microsoft ADFS or Okta, to basically do that federation with AWS IAM. So your AD users essentially assume that role in AWS and then can access the resources in AWS. Now onto our third topic, which is SQL Server. And if you're going to talk about Microsoft workloads, chances are there's a SQL Server somewhere in that workload. And seeing that SQL Server is a database and contains data, and data for most companies, that's their crown jewels. It's really important that you have a highly reliable, a very secure platform and architecture for that SQL Server. As well as SQL servers often are the linchpin in your application, so you need to make sure that they're efficient from a performance perspective. Otherwise, other parts of your application can slow down, as well as they're often the most expensive component of Microsoft workload architecture as well. So we want to make sure that we can cost optimize those. So there's a very common option that we see a lot of folks do, and especially if they're coming from on-premise, is you can just run SQL Server on EC2 like you would run in your data centers. This gives you really full control, full sysadmin privileges of the SQL Server. You manage the virtual machine security, the storage, the network ports. It supports both modes of authentication. This also gives you multiple options on how you can set up high availability and disaster recovery on SQL Server. So you can use mirroring, you can leverage always-on availability groups, transaction log shipping, and we even see some customers use failover cluster instances. In that case, when you're looking at using a failover cluster instance, oftentimes you'll have to use a third-party tool, as EBS volumes can't be shared across instances. So a very common HA DR technology that we see our SQL Server customers use is always-on availability groups, leveraging our multi-AZ global infrastructure. And so how this works is you set up a primary in one availability zone, and you set up a secondary in another availability zone. And always-on lets you do synchronous commit and automatic failover for a cluster of databases, unlike mirroring, which is set up for a single database. And so what this actually also gives you, as well as always-on, provides the concept of read replicas. So you can have your primary read, or you can have your writes and some of your reads go into your primary, but then you can load balance additional reads. So oftentimes that's a BI tool or reports can run against that secondary that's running in the other availability zone. Now we have some customers that want to build global infrastructure, and they need to be highly available across multiple regions. And always-on availability groups also gives you that functionality. So you can set up always-on, just like we did in the previous slide, across in one region, and you can have synchronous failover or a synchronous commit within that region. But then you can also set up an asynchronous commit to a different region. So in this case, if there was a failure at the region level, you could still fail over to a completely separate region. Now, there's another option when it comes to running SQL Server, and that's Amazon RDS. So this is a managed database service, kind of similar to the AWS Directory service for Active Directory, but we will, has automatic patching, backups, and mirroring. We'll have automatic host replacement, so we'll protect you in the event of a hardware failure. And you're not just limited to SQL Server. You can run Amazon Aurora, which is our open source database, Oracle, Postgres, MySQL, MariaDB. And so HA and RDS is, again, it's pretty much just a checkbox. When you go to set up the instance, you can click checkbox saying you want a multi-AZ deployment, and we will build that SQL Server across multiple availability zones. We'll provide automatic failover, automatic host replacement, automatic backups, and we'll do automatic software patching. You can disable this, and you can also set a maintenance window so you can define the terms of when your RDS instance is patched. With Amazon RDS, as opposed to the previous example where you're writing this on EC2 and you had to configure a highly available solution, you can choose to use RDS, and it's a complete managed service. So you no longer have to worry about the operational aspect of writing SQL Server. You can focus on your application. Now on to the fourth topic, which was developers, tooling, and the developer ecosystem for Microsoft developers on AWS. If we go back to this slide again of talking about these different pillars, oftentimes when you're building or you're deploying commercial off-the-shelf systems on AWS, sometimes you don't have a lot of control over how things get deployed. That's just the way they get deployed. But with developers, I would say the well-architected framework is even more important because developers often have lots of decisions that they can make on how they build their applications. So it's really important that you make sure that it's secure, it's reliable, it's cost efficient, and performance efficient, and that you can operate it well. So with Windows development tools, if you talk to any Microsoft developer, they're likely going to tell you these are their tools in the toolbox. Visual Studio is a very common and popular integrated development environment. There's VSTS, which is a Visual Studio Team Services. It's a fully managed application lifecycle management solution running on the cloud. NuGet, which is a package management system, PowerShell, and command line. And so these are our tools that complement that typical Microsoft developer toolbox. So we have the AWS CLI that you can run on Windows. We have the AWS SDK for .NET, the AWS Tools for PowerShell, and we have toolkits for Visual Studio and VSTS. So if you were to map these, this is really how that tooling that a Microsoft developer would use, how that maps to the tool ecosystem that we support for Microsoft developers. Now, if you're familiar with continuous integration and continuous delivery pipelines, should be familiar with this slide and these concepts, but continuous integration is just the continuous integration, the building of your code to making and running tests. Continuous delivery is taking that beyond the building and the testing and doing actual functional tests and deployments, usually with a gated mechanism. And then continuous deployment is basically taking this even a step further and just doing automatic deployments to production. If I were to talk to a Microsoft developer and they didn't really have a CI/CD process, a continuous integration, continuous delivery pipeline in place, I would say consider using managed services. So we have a series of code services. We call them code star services. We have code commit, which is a Git repository, a managed Git repository. We have code pipeline and code deploy, as well as services like Elastic Beanstalk and OpsWorks that allow you to deploy your application to infrastructure on AWS. So here's an example of a .NET CI/CD pipeline leveraging code pipeline, AWS code pipeline. And you can see here that we're leveraging S3, so that source bucket, and then we have a Jenkins build server that is pulling code pipeline to look for code it needs to build, and then leveraging code deploy to actually do the deployment of those artifacts to servers. Now you can actually, if you're building .NET Core, we have native support now in AWS Code Build. We also just published a blog article. There's a link here that shows you how to build a .NET Framework application code build. So you can leverage an AWS build service and build both .NET Core or .NET Framework. Now, if you have an established CI/CD pipeline in it's quite common to see Microsoft developers leverage Visual Studio Team Services or Team Foundation Server, and if that's the case, I would advise those customers to continue to use that tooling and leverage our great tool set around VSTS and TFS. And so within VSTS, we have a rich set of tools that integrate directly within that software solution. So there's different tasks for deployment. You can take your VSTS application, deploy to CloudFormation to Beanstalk. You can even do .NET Core deployments to Lambda, as well as a bunch of general purpose tasks. So you can do S3 uploads and downloads, you can invoke Lambda functions, you can send an SNS message, or you can even just call the AWS CLI as well. So the following are just a few screenshots of our toolkits. This one is showing our AWS Explorer in Visual Studio that allows Microsoft developer to navigate many of our resources directly in their development studio, as well as there's functionality here to right-click on the project and click Publish to AWS. So it makes publishing your code to AWS very easy. On top of that, we also offer a bunch of starter templates. So these are project templates built to allow you to build console apps, web apps, other common Microsoft developer apps, but build them in such a way that they're easy to get started with AWS. So they're including the AWS SDK for .NET as well as other artifacts. We also offer a bunch of boiler templates. So you can actually build Lambda functions with other languages like Node.js, or you can build CloudFormation projects directly in your Visual Studio development environment, as well as using Elastic Beanstalk to do a one-click or a one or two-click deployment to AWS. So you can right-click on your application, say publish, and it will publish to Elastic Beanstalk. So just to keep in mind that the AWS Toolkit for Visual Studio, it's an extension for Microsoft Visual Studio, and its purpose is to make it easier for developers to develop, debug, and deploy .NET apps using AWS. So, by using the AWS Toolkit for Visual Studio, you'll be able to get started faster and be more productive when building AWS applications. And think of that toolkit and the AWS SDK for .NET really as a gateway to leveraging 100 plus other services. So not only is AWS a platform to deploy your .NET application on, it's also a platform that you can leverage within your .NET application. You can leverage things such as DynamoDB, which is our NoSQL solution, or Amazon S3, our object storage, and 100 plus other services are at your disposal. So oftentimes when I talk to customers about Microsoft applications, the question is, quite often asked, how do I move my application? What direction should I go? I'll often talk to a customer and they will have their data center and they may have hundreds of Microsoft apps, ASP.NET apps, and they want to know which approach do I take? And really, we'll typically, when we discuss any sort of migration with a customer, the three scenarios we typically will talk about are the Rehost method, the Replatform, or the Refactor. And so just keeping these the pillars of the well-architected pillars in mind as we discuss these three options, the easiest way is to simply rehost. And the best service to do this for a Microsoft .NET application is going to be Elastic Beanstalk. And Beanstalk gives you a lot of that highly available functionality, operational excellence, a secure platform to deploy your application in. So out of the box, it gets you or brings you load balancing, health monitoring, and the ability to auto scale. Really all you have to bring is your code. We'll even help take care of deployments and doing a blue-green deployment and doing rolling updates. So if you're going to your goal is simply to get your application to AWS as quickly as possible, my recommendation is leverage AWS Elastic Beanstalk to move that application. The next method, so we talked about Rehost. There's also Replatform. And so oftentimes this will look a lot like Rehost, but what I would recommend is if you're going to re-platform, start looking at the easy things that you can switch on your .NET infrastructure, your architecture. So oftentimes this is going to be, you can take out Active Directory and put directory services in there. You can take out SQL Server and EC2 and then just leverage RDS, and you be able to take advantage of that one-click multiple AZ architecture. And then we have other customers that decide they want to fully refactor and they want to go completely cloud native with their .NET architecture. And this is when you start talking about serverless functionality such as API Gateway and Lambda and leveraging DynamoDB, S3 and CloudFront. So it's really up to you. As you get to this refactoring stage, often your application will get very cost effective as opposed to just lifting and shifting onto EC2. Because really you have to often balance that time, the time it takes to get to AWS versus with how cost efficient you want your architecture to be. Now the last topic that I want to touch on is the administration of Windows servers. So we have Amazon Systems Manager that is being built to help you manage and scale the management of EC2 Windows instances. It also supports Linux as well, but it fully supports Windows as well. And so there's a bunch of components here on the screen, and really you can put those up into, or divide them into three categories. We have the run command and state manager. So these allow you to deploy and configure and administer your Windows instances. We have some shared capabilities. So the maintenance window and the parameter store. So the parameter store is a way to securely store parameters that might have sensitive information, as well as the inventory component, patch manager, and automation. And these are used to track and update your instances. So with the run command, you can safely automate very common administrative tasks on your instances at scale without needing RDP. You could run PowerShell across 2,000 EC2 instances straight from the console. While something like inventory is a component that allows you to collect and query your software inventory. So imagine you have hundreds or thousands of Windows servers. You can leverage inventory and System Manager to collect all the information about what's installed on each Windows instance, as well as Patch Manager, which allows you to select and deploy which OS patches and how you want to automatically patch different groups of Windows instances. So this is just an example of how you can use a System Manager to help you, achieve safe and secure operations at scale. And again, going back to that well-architected framework, this is really talking about the operation excellence pillar. So now that you have your application, you built it, it's secure, it's highly available, it's cost efficient, it's performance efficient. How do you actually achieve the operational excellence? And this is a really key tool when it comes to running Windows instances on AWS. And the nice thing about System Manager is it also allows you to install the agent on-premise. So not only can you manage your EC2 instances, you can also manage your Windows instances that are running in your data center. Just another example of System Manager and how it can help you create software compliance and reduce risk. So you can use System Manager to basically, bootstrap your instances on launch with an image built or an image that you've built that is compliant with your requirements, and it allows you to roll out patches based off corporate policies and org-wide maintenance windows that you've defined for your business. And it also helps you get notified on if there's malwares, blacklisted apps, and you can take recommended actions based off of that. So just wrapping this up, AWS helps you build, deploy, scale, and manage Microsoft applications quite quickly, easily, more securely, more cost effectively that you can run in your data center. And by combining this with the well-architected framework, you can ensure that you have your Microsoft applications and they're being built using the most secure, high-performing, resilient, and efficient infrastructure possible. And now we have some time for questions.